Here's the program from the previous video. I want to illustrate a little bit more about these comparisons and things like that. So what I'm going to do is delete all this, and I am going to say move. Actually, let's just get rid of all that. Let's move into EAX some magic number that I am going to type off the edge of the screen so that you cannot see it. Alright, so let me pause the video and actually do that. Okay, so off into Netherland on the right side of the screen, I have moved into EAX a value. Now I want to compare that value and see if it's equal to 5, less than 5, or greater than 5. Alright, so let's just do that. I'm going to say compare EAX to 5. Alright, and then I'm going to put some labels here. Let's say less than 5, equal to 5, and greater than 5. And down in here we're going to, let's stuff some value in EBX indicating what our result. So if we're less than 5, we're going to move into EBX the value -1. If we're equal to 5, we will move into EBX the value 0. And if we're greater than 5, we're going to move into EBX the value 1. So you kind of think of this as if it's less than 5, EBX will set to negative. If it's equal to 5, we'll set EBX to 0. And we've seen how when things subtracted from itself, it makes 0. And if it's greater than 5, we'll set it to 1. No special meaning in any of this. I'm simply trying to give the debugger a place to go after we do our compare. So compare EAX to 5. Let's jump less than to the less than 5 location. We will jump equal to the equal to 5 location. And then we will jump greater than to the greater than 5 location. Alright? Now you may think, that's interesting. 3 jumps in a row, but this is how it goes. Remember, the compare instruction will set up the sign flag and the 0 flag for us. And then these conditional branching statements, all they do is examine those flags. They don't actually change anything. The only thing these branching statements will change is the instruction pointer if the condition is considered to be true as far as the state of the sign flag and the 0 flag. So jump less than, I'll look at those 2 bits and determine whether it's less than. Jump equal to, if it is less than, it'll go directly to here and skip the rest of these checks. Alright, but if it's not less than, we go to the next one and say, hey, if it's equal to 5, then skip this one and jump straight to here. Now if it's greater than 5, well then we'll jump to greater than 5. Now hopefully one of these will be true. I mean, I can't think of any other condition. There's no number I can compare against 5 that will not be true for at least one of these. Alright, so let's see if we can figure out which one. I'm going to hit F11, undefined symbol greater than 5, because I spelled it out. That's interesting. I said F-I-V-E there, and then whatever. Okay, F11, Control D, F11. Move into EAX the value 3. Oh, look, there's my special hidden value that was off to the right of the screen. Alright, when I compare 3 to 5, what's the result going to be? What's going to change? That's the magical question. When I run this line of code, what will change? Alright, pause the video, think about it. Well, 3 minus 5 gives me a negative non-zero number. Alright, that will give me a -2. Alright, so our sign flag will be 1, indicating negative, but our 0 flag will be a 0, indicating not equal to, okay? So, and that's indicated here with the flags register, as we've seen several videos prior to this one. So F11, you can see we have a 9 there. We've seen 9 before in previous videos. Alright, so jump less than or equal to. With the state of these 2 bits, is 3 less than 5? Well, yes, it is. So it's going to jump to this instruction address right here, thus changing the instruction pointer to that as well. Boom! And then we can move into EBX a -1, which, if you remember from the binary playlist, this is how we represent a -1, like so, basically turning on all the bits. Okay, well, also notice that in our original code, let me new vertical tab group this. we just executed this instruction, but now our instruction pointer moved on to the very following instruction, which is this one. So it's not like we just skipped over equal to 5. These are not mutually exclusive decisions. We jumped to less than 5, we did this, but then the instruction pointer, as it should do, just moved on to the very next instruction, which is right here. And so now it's going to execute the logic we had for equal to 5. We need a way, now that we've jumped into this, we need to jump out over all the rest of it. Can you think of a way to do that? I've shown that in a previous video. Pause the video, think about it if necessary. Let me clear all this off. Shift F5 to stop the debugger. Let's bring our assembly code over here. And now that we've done the less than 5 logic, whatever that is we wanted to do, in this case move a -1 into EBX, we need to conditionally jump out of here and say done, like so. So let's jump to the done location. Right? We are unconditionally jumping. We are not going to check less than equal to or anything. We've done what we want to do, and let's go past that. Well, we need to do the same thing here, and we need to do the same thing here. Jump to done, jump to done, jump to done. F11, Control Alt D, F11, and here we go. Let me see if I can get some screen real estate. All right, compare 3 and 5. That's still less than. So now we jump to the location of less than 5. Notice this label. Again, we've seen this. This label was changed into this address, or no, not that address, this address right here, which we set the instruction pointer to there. Sorry, it's kind of cramped here. We move into EBX, the -1, and then we can, not conditionally, we unconditionally jump to out of here, which will take us to this location in the code, which is down here at the return. So watch this jump. Jump, boom. Okay, very cool. Notice the well, before I say that, let me change the magic number I have over here. Oops, I don't know what. Yep, there's my 3. Let's change it to a 5. All right, so when we do the compare, 5 will be equal to 5. Thus, the 0 bit will be turned on because the value is 0, and the sign flag will be set to 0 because the value is not negative. Let me F11 on that. Control Alt D. F11. F11. Here's the compare again. Pay attention to this value here. Pop. It's a 4. It didn't change because the values were already set accordingly, but it did. The compare did do the evaluation, and our sign flag is a 0. The 0 flag is not set, and then the other 2 bits. Let me just draw them out here. There's a 0 and a 0. So that's a 4 in binary. So what we had there was correct. Let me get that off the screen. Okay, good. Jump less than. Well, is it less than? No, the 0 flag is set, which means it's equal to. It's not less than, and the sign flag is, or the 0 flag set, which means it's equal. Then the sign flag is a 0, meaning it's not less than. So watch what happens. The instruction pointer just goes on to the next one, and we say, hey, jump equal to. Well, is it equal to? Yes. The 0 flag is turned on. The 0 flag is turned on. So it will jump equal to this location, to 5, which indicates our equal to 5 code here. So right here, boom. We change EBX to a 0. It's already a 0. But anyway, and then we jump straight out to the end. All right, so hopefully you're seeing here, and hopefully I'm not confusing you too much, that combining conditional branching statements, like so, with unconditional branching statements, we're able to do different logic depending on certain conditions that exist. For example, I'm saying, hey, it was a 5, it was a 3, and if you change it to a 9, it'll jump to the greater than location. Right? Now, I think this program actually illustrates a little bit better what I was trying to prove in the last video, was branching. If you think of a tree branch, right, here's a tree branch, but then it can branch out like so. And if you think of our code right here, it comes in like the tree branch, but then down here at one of these points, we can jump less than to here, or we can jump equal to here. Right, here's our other branch, and then we have the last branch greater than or equal to 5, which will branch out to here. All right, but then at the end of all of them, if it jumps into here, then we jump done, which we go back to here. We branch again. Right, this one, it'll jump to done and end up at the same spot. and greater than or equal to 5, it'll jump down and end up at the same spot as well. So you can see how we kind of branch out as a tree, but then eventually we converge back again, and this will keep going on to the return statement, which I probably shouldn't say this, but the return statement's actually a branching statement too, even though we haven't talked about it, and I'll show it when we get to procedures. Anyway, whew, there you go.